Hi, everyone. Thanks for coming. My name is Rothman. I work at Beeswax, where we build great advertising software. We're about 30 engineers working in a monorepo. To date, we've built about 100 applications comprising 300,000 lines of Python code. And the problem we faced was how to manage our third-party Python dependencies. By third-party, I mean something you'd install from PyPI using pip, things like requests, Boto3, Airflow, NumPy, etc. When we Bazel test or Bazel run some target, that target's third-party dependencies have to already be installed. Not only that, but the dependencies of every other target in its transitive closure also have to be installed. And those same dependencies have to be installed in production when the application is deployed. Now, when we had just one or two applications, we solved this pretty naively by putting all of those applications' dependency into a single requirements.txt file and just deploying that everywhere. As you might guess, this didn't scale very well once we had a critical mass of applications written by multiple engineers. We quickly ran into version conflicts and other problems. And so we looked at rules Python, So we looked at rules Python. And we discovered that rules Python can't guarantee that you'll import the correct version of a dependency, and that was unacceptable to us. So we took a look at pipenv, which is the Python community standard for managing dependencies and virtual envs. But the problem with pipenv was that it doesn't work well in a monorepo unless you're willing to make some major concessions, which we weren't willing to make. And so that led us to roll our own solution. Our solution, which we call Beev, is a set of tools built around Bazel and pip tools. Pip tools is an open source project that's used by pipenv. It does pipenv's heavy lifting. And Beev is what we use to manage our Python dependencies. Beev is composed of Starlark macros, rules, aspects, and some command line tools that we wrote. And its output is a lock file, one lock file for every application. When I say application, it's interchangeable with a PyBinary, let's say, just in Bazel terms. Think about it that way. So there's one lock file per application. A lock file is a set of third-party dependencies, each one pinned to a specific version. You can think of it as an application's requirements.txt, but one that's auto-generated by Bazel as needed. So here we leveraged Bazel's ability to walk the dependency graph and collect all the third-party dependencies for every target in that graph. And we leveraged pip_tools' ability to take those dependencies, resolve them, and generate a lock file. So then we take each application's lock file and we use it to generate a virtual env, which is where we do our development and unit testing. And we take that same lock file and we generate a wheel, which we use to deploy the application. So here's an example. This is a toy build file with some application. It's got 3 targets. And note that we've annotated each Python rule with a new attribute called requires, which takes a list of pip dependency specifications. So here, a dependency specification is just a constraint on which versions of a package are allowed to be installed. Also note that we have a PyVenv rule. This rule tells Beev that we want to generate a lock file for the associated PyBinary. When we Bazel run the PyVenv rule, the Starlark code behind that rule generates a requirements.in file, which, as you can see, is just the union of the requires attributes over the transitive closure of the PyVenv rule. Beev then calls pipcompile to take that requirements.in file and generate this lock file. The lock file contains pinned versions of all the dependencies in the requirements.in file, as well as their transitive dependencies, and so on, which is just another way of saying that it's the complete set of Python packages that our PyBinary needs in order to run. Nothing more, nothing less. It's the precise set of those packages. Note that generating this lock file is not hermetic, nor is it reproducible. That's because it depends on the current state of PyPI at the time you generate it. If you run pipcompile in the same in file 2 times, you're not guaranteed to get the same lock file as output. But you are guaranteed that the resulting lock files will conform to all the specifications, all the constraints in the requirements.in file, and that's what we really care about. So how did it work for us? Well, one of the downsides is that developers must now be aware of Python environments where they didn't have to before, and they have to explicitly switch between them to run Bazel tests, say. And that's error-prone. We'd like to get rid of it or reduce it. We also inadvertently made Bazel's caching less effective. And changes to third-party dependencies aren't automatically propagated to the Pi libraries and Pi binaries that are downstream from them. Right now, that's a manual step. We hope to improve that too. On the plus side, we did achieve our most important goal, which is to reliably know the precise set of third-party dependencies that every Python application has. That is the set that contains everything the application needs and nothing that it doesn't. Our solution is monorepo friendly, which should go without saying because we're a monorepo. And it has the nice side benefit that we can now track dependency changes over time because our lock files are checked into Git and we have their histories. And last but not least, we can easily produce wheels for our Python applications, which has made deployments a real breeze. So I'm happy to talk more about Beav or Python dependencies. Please feel free to email me with any questions or just find me at the conference. Thank you.
One question? If there's anybody.
Fight it out.
So if every library is imported by any other Pi binary, is that the case right now? Or not? Is any Pi library usable in any other Pi binary within your repo?
Yes, exactly. Oh, thank you. So the question was, in our monorepo, is any Pi library able to be depended upon by any, say, Pi binary or other Pi library in the repo? And the answer is yes. We don't impose constraints over that. That was one of the starting assumptions.
Which means you can have one log file for the entire repo, essentially, and have, like, safe, like, it'll boil down to one version of request, and one version of NumPy, and one version of Airflow, if you did everything correctly.
Well, so one thing I didn't mention explicitly, I had to cut the talk significantly, but every time a dependency is specified, it can be specified at a particular version or a version constraint. And so if we could try to build one requirements file for the whole repo, but what we would probably run into is version conflicts, where some library somewhere required, some version less than X and some other one required greater than X. We would, in fact, because I've tried it. So. Thank you.